together. But hey, Sai's very talented. He's very smart, but he's still very young and new. So the way we're going to do it this morning, it's going to be a conversation presentation between the two of us. And so when I present a slide, he has a question, he's going to ask a question. When there's something he likes, he's going to talk about that. And then over time, we're going to ease the transition from it being more like a conversation to being it more like co-presenters. But we'll get started with that and I'll share it. And yes, let's see. I'm trying to, okay, good. And help me out with the chat, Guy, then we'll get going here. So I'll go into presentation mode. So Sai, I think there's two parts to explainable AI. There's the pre-modeling and the post-modeling. And I want to make a big distinction between the two. What questions do you have for me about that?
Like you catting, if am I audible?
Oh yeah, I can hear you.
Yeah, like you categorize like pre and post explainable AI. So then my first question would be, why did you feel like there should be an pre-explainable AI and the post-explainable AI? Like it can be simply explainable AI, right? But you divide it into two parts, it is pre and post. Like, what is the reason behind it?
Yes, because as I started appreciating more why explainable AI was important, I thought, and also as I read my brother Dennis's book, it occurred to me he had the same emphasis. He wanted to understand things before we had model output, and I applauded that, but I was already thinking the same way, quite frankly, before I read his book, to say, well, why aren't we using, now, Sai, you've heard that we do like 80% of our modeling work before we get to modeling. I think that 80% of that work is 80% of the value that we can explain to people outside. For example, Sai, if I have a model prediction, that's the post. Now, if I have to explain the model output without using that pre-modeling stuff, that gets really hard. I'm not saying it can't be valuable. I'm just saying, can't we just go ahead and also use that 80% of the work we did and explain that to give greater insights? Because Sai, in that work, we find out which features are most important if we've done it well. And the business can act on that feature importance right away. It's part of our data storytelling. That's probably 80% valuable, and the predictions are probably 20% valuable. It's interesting. I think it roughly goes hand in hand. So does that make sense?
Yeah, so basically you want to sum up like that. Like if I sum up, like you want to have explain how the process goes, then the result. Like you want to focus more on the process, and that's why you divided this pre and post explainable AI.
Perfect. And think of it this way. We don't have to ask our non-data science friends that should understand this stuff to be experts at data science, but we can share the insights we're learning from the machine learning pipeline and from the model predictions both. But there's a lot of value on both sides. So let's go to this. And this is how I'm going to walk you through this, Sai. We've got the pre and post explainable AI, and we're going to start with why we try many models. And because we do, or we should. Unfortunately, I've heard of some organizations, they always use the same type of model. And some of my friends went to work at those places and they tried to suggest we should be trying other types of models, and they got ostracized. And that's a horrible data science culture right there. But we want to also cover what are the values of models. And when we talk about parsimony or simplicity, what can that mean? And then what are the current best post-explainable AI methods? And then we're going to suggest to the audience to look at two examples in code from Dennis's book. And then we're going to try to think beyond, like both beyond in the before of all of the explainable AI and the after. Like, how can we integrate brilliance of other areas into this thinking? And then just a great mentor from my past, he used to ask me when I would bring something exciting to him. He was one of my advisors in grad school. Thom, so what? Now, he wasn't saying he didn't agree with me that it was important. He was challenging me to make it more valuable. So we'll go through these points. So why try many models? Now, I want you to ask me any questions you have on this. Our data is usually a sample from a much larger population, even when we have a lot of data. So does that make sense, Si?
Yeah.
So it's even if it's a lot of data, the whole population of data we could get is huge. But we can only know we have a little bias when we can measure approach to the central limit theorem. In other words, let's review the simple side of the central limit theorem. We take the average of that data that we have. Now, when we collect that much more data again, we take the average of that or the mean. And if we start to plot those means, we know we're approaching the central limit theorem when we see a Gaussian shaped distribution of those means. That's the central limit theorem. So even when you try to avoid bias by all human means possible, you might have missed something, but even if you miss nothing, there could still be bias. And that's why we have to try all these models, because we don't know which one's going to deal with the current bias the best. Does that make sense?
Yeah.
Okay, cool.
Completely.
Now, basically our data has bias whether we like it or not. But another point, we try many models for each data set. What we find is one model will deal best with our current bias than others. And as we see changes in our distribution of means of our data assets growing, that's when we have a clue that, oh, okay, I should try new models or new hyperparameters of the model I already have. And so we just seek a great balance between accuracy and generality along the way too, because sometimes we get into slight overtraining or undertraining, and we also have to try these different hyperparameters for each model and different models. Does that make sense?
Yeah, Dad. Like, I just had a question that you mentioned about best. So what is your meaning of best model? Like, is it model with a best accuracy or the maximum accuracy, or which makes sense simply?
That is a perfect question. We don't want to get sucked into thinking the most accurate model in training was the best. This is why we do special techniques to make sure that our model generalizes well, because for our training set, we might get very accurate predictions. But as more data comes in, we might not get very good predictions on that. And as we predict the labels, then later we can figure out what the actual labels were. We could see how that new model's doing. But there are special techniques we do to increase the chances that our models were generalized well. In other words, they'll also predict well when new data comes in. And we'll talk about those here a little later on. But does that help?
Yeah.
Excellent. Okay. So why do we try many models? Continuing on, we also want parsimony. And in the simplest word, that's the simplest model that will do the job. It's not too few features. It's not too many features. But why do we aim for that? It's easier to train, but more to this presentation, it's easier to explain. If we have too few features and it's not accurate, the model's not very accurate because of that, or we have too many and it's inducing noise, it's just going to make it harder to explain, because we're trying to explain things that shouldn't be there or that should be there. And sometimes we can use neural networks or deep neural architecture. And what's nice is those are really good at doing all the tricks that we use for, say, linear regression. But other than it being trainable with less resources, it'll be easier on post XI tools if we avoid neural networks. But Sai, here's the good news. We could still use a neural network or a deep neural architecture, but we could use simpler models to explain things too. In other words, by looking at many models, we can use some of those models for explainability and some for prediction. Does that make sense?
Yeah. And Tom, I just wanted to add something from Dennis' book. I really loved that. That is DPA. He used one symbol, that DPA, and which means development for XAI model, production for XAI model, and then third one was accountability for XAI model. And I really loved that because like you said, that one's for predicting the model, predicting something, and one for explainability.
Yes.
So
and to this point here, let's say we know we're going to use a neural network or a deep neural architecture. Well, it's now we can train it with less resources, because as we all know, neural networks and deep neural networks, they require a lot more data to train accurately. Now, not a simple neural network. So if we've simplified the neural network, now it's easier to train, it's easier on the post explainable AI tools, etc. Does that also make sense?
Yeah, it makes sense, like possibly.
Okay, cool. Now to the next point. What is the value of models, or the values of models? Well, they predict things, but they're all wrong. However, if they're good models, they're still useful. And from the first day I was really learning modeling at the university level, it was a least squares fit of, and I was doing this manually, Sai, but just to realize, oh, I've got a line that passes through all these points using least squares, ordinary least squares, and I did it by hand. It doesn't pass through any of the points, but it comes the closest to all the points. And so was the model completely wrong? It was absolutely completely wrong. It didn't predict any of those points, but were all those points trustworthy? That's the funny part, because they probably they were bouncing around the line because there was measurement error. And in reality, because we typically have Gaussian distributed error, Sai, if that line's passing through the middle of a really large number of points, if we could remove all noise, it's a good chance that line is close to exact, closer to exact than we knew. So yes, George Box was correct, but he's just trying to really drive home a point. If we fit every point exactly, then we've overfit. The model won't work well on new data. And that's a key point. Does that make sense?
Yeah, absolutely.
Now, here's a cool thing though. Once I have a model, I can perform sensitivity sweeps with each input within reason. In other words, I can begin to say, oh, I've got this range of feature values for this feature, but what if I extend it? Well, that's me experimenting about possibilities. And then I think, well, okay, we got this feature weight, or this coefficient for the model for that feature, but what if I could increase that feature weight or decrease it? Well, that's going and affecting the processes that caused the data to have the values it did. That's when we can start to really think about it with our business counterparts. Does that make sense?
Yeah. It's clear,
So
yeah.
now, how big is the within reasons? That's why we make friends with our domain experts. And that's why I have this funny question. Get to be friends with them, and talk to them about what you're doing. Check in with them frequently. Now, I can sweep some feature values and hold some constant and ask what if. That's the kind of experiments you want to do with your domain experts. And you can even hand off versions of your model so they can experiment with those things. But sweeping across features is a key modeling skill. So that's why we have to work with domain experts at that point and exploit that feature input sweeping. It's very much like what we call in the engineering realm design of experiments. Okay, I'm going to go on. And by the way, we're doing this mock conversation because Sai is really a good student of this, but we're going to open it up to family questions at the end, and we can go back to specific slides. So this is Sai's slide, and he's going to present this, and I'm going to ask him questions.
Yeah, so first of all, I must admit, whatever I've learned majorly of AI, XAI, it was completely from Dennis' book. This is something which of one of my favorites, you can say, example that he has given in the explainable AI. So there's a case that there's a person called Jane. He went from Paris to Chicago and for a vacation to meet his friends during the month of September. And when he went over there, there is a virus called West Nile virus. I'll just explain. I'll just take a minute to explain about this virus. This virus is something which originates from birds and animals, and its endpoint is human beings. Like after human beings, it can't. It's a dead. You can say it's a dead virus in humans. It can't propagate, or it can't just spread from human to human. So Jane suffered from that West Nile virus, and he went from Chicago to Paris, his home country and home place, and where he noticed that there is something inside him that like he was getting frequent fevers and stuff like that. So and he was it was being hard for him. So he went to a doctor, his doctor, and he said that this is what I'm suffering from. And his doctor said, okay, we need to do some tests. And that was a time when COVID-19 was also on the rise. That is, so it was very, and he was suffering from cold, fever, which was also a symptoms of COVID-19. So doctor initially he took the help of AI that was there, that was present. That okay, let's take a help of AI, and he tried doing that stuff, but he was unsatisfied with the result of AI. So he went to his that AI related person in the hospital itself, and he said that I'm not satisfied. Just help me out with it. So he was like, okay, we'll just figure it out what happened to him. And the first question of him was, where did he travel? Like, is there anything where he traveled much? And he was just traveling a lot. And then it was decided that he was traveling. He said he has traveled to Chicago. So when he traveled to Chicago, he first of all he took his Google history, and he just take care of all the things where all the places where he went, and the and all of these. He also tried to find out about the diseases which are there inside his locality, like what are the diseases which are found in the Chicago. So there was a set of diseases, and among which West Nile virus was also one of them. And later, after many things, that he found out that yeah, there is something which is not the normal thing which AI model has predicted. And by that time, doctor has completely lost faith on AI model. The reason for it, because AI model was not giving an appropriate you can say solution. It wasn't unsatisfactory, because when you're a doctor, you can't expect a doctor to learn the AI language or data scientist language people. So there you need to have an explanation that is called as natural language explanation. That's something which doctor needs. But AI model was unable to provide it. So that's when he went on and he made lots and lots. The challenge for AI was that it was limited. It was predicting, but there was no explanation for it. Like, okay, it predicted that, yeah, he's suffering from cold. how is it suffering from cold? Doctor should know, because that's when there's a clarity in his mind that, yeah, now I can give him this medicines. So it was the biggest challenge for the AI normal models. That's when the AI related person in the doctor, in the hospital, he went for that for the other precautions, and he totally analyzed the problem. Where did he went? The first thing what he did was, where did he went? What did he eat? Eatings, he asked him, and for as I said, he used the Google location history also, and nearby virus, and he find out that his symptoms are matching with West Nile virus. So that's how we found out, and I really hope I have.
What do you think? What do you think is the key takeaway though for this story?
For me, it's that AI models are it predicts, but we can't say that whatever it predicts, we get the proper explanation for it. Like for example, a KNN algorithm we can use, and we can there's a nearest model, and we can simply predict that, yeah, there's a line, here's one line, we can just, there's a distance, and we can find it out. But what is happening, we need to have a clear explanation for that, because whenever we are dealing with, as an AI person, at the end of the day, we are dealing with somebody who are not from AI background, and we are.
But would you say this, Sai? Would you say the AI model both didn't have the information it really needed and wasn't trained to deal with the information it really needed? Is that accurate?
Yeah, it is completely accurate, because it had information, but the information was very limited. That's
So
what
can I interrupt you for a while? I think it will be because how I take this example, and I wish Dennis maybe can correct me since it's from his book. I feel that you're just telling us that don't use a gun to fish a mosquito. This is not a good thing to do. Mosquito, you can find another way to hunt it, not by gun. And the AI model here, it's a gun, but it's not designed for this kind of activities.
Exactly.
Something like that. This is what I get
exactly
from the example. Now I need a correction. Maybe
well, and I agree with you guys. I'm seeing this the way Sai's explaining it, and from remembering my reading of it in Dennis's book, that hey, the model, doctor, don't lose faith in it. Work with it. It's confused. It's saying a cold, but you are able to collect more information specifically on this one data point, this one person, than the model can do. So the doctor was absolutely correct to ask the travel history and figure out, hey, what sicknesses, what infections are going around in the places this person traveled. And voila. It's a partnership.
I totally agree with you, Thom.
What do you think?
Guys, it's not that I'm saying that completely lost faith in AI model, but if you take from a perspective of doctor, he has lost initially the faith on AI model. So I'm just saying that we sometimes there are no conventional results for one thing. Like there might be a multiple results which are when noticed or we haven't faced, like AI model hasn't seen that kind of mosquito bite before
Right.
that.
So Sai, let's do this. Let's go on, and then we'll have you ask Dennis's perspective on this story at the end, okay?
Yeah, I'm really
and we got
to
listen. we got to get there before soup time. So that's the only reason I'm pressing us to go on. Now, Sai, the model you put into production may predict the best, but the most easily explainable model may not be put into production. And that's okay. So do we have to choose between best predictor and most explainable? And this is a famous meme now, Iron Man 1, right before Tony Stark is having the hillsides in the background blown up by the missiles that his company makes. Respect or fear? Well, is it too much to ask for both? And I would have rather loaded the video here. But the point being, hey, we try many models. we can use different models for different purposes. So the point being, we don't simply put one model into production for all time and never replace it either. Outside of production, even, we're monitoring model performance, we're looking for new data issues, we're tracking statistical significance of our data sets. Hence, one of the many things is our approach to the central limit theorem. And we're testing many models still to see if the model being used should be updated with new weights or replaced by a new model. So the point being is we're using multiple models all the time outside of production to see if we can put a better one into production, but also before the actual official modeling step in the pipeline, see, hey, what model can give us better explanation? So now, simple is an important word, or parsimony, more importantly. What can that mean? Well, how do we make simple and more explainable models more accurate? Well, first of all, don't be so model-centric, be data-centric, because we all know this. You feed your models garbage and expect champion models, yeah, that will fail. But do careful feature selection and feature reduction and outstanding feature engineering. Do great hyperparameter optimization when necessary. This is all very data-centric, and it can make a simpler model perform as well, maybe better than a complicated model. So we start with simple models always, and we upgrade to more complicated models as needed after we've done really good work on the features on our data. And so we really want this because it's warranted for more performance. It equals a better balance of good accuracy and generalization. So we still keep simpler models accurate as possible, though, for explainability. For example, I'm presenting and I'm using one model for explanation and one for prediction. My stakeholders might challenge me. Well, you're using that one for explainability, but is it very accurate? And I want to be able to say, it's pretty accurate. It's just not as good as this more complicated one, but it still gives value. And this is, I made this meme. I'm proud of it. My model's more accurate. So what? My model uses deep learning. Big so what? And then Pavarotti, of course. And I was tempted to have him say, you idiots, but I didn't, because these guys are awesome singers. My model was trained on better data, is adequately accurate, generalizes well, and our org leaders understand it and found it insightful. We're trying to learn from the models. We don't have to completely understand why they did what they did, but we want to learn as much as we can from them. So now, though, we get into what are the current best post methods. And by the way, you pick up probably the top book on explainable AI written by Dennis Rothman, and what do you find? He's doing a lot of explainability things before the predictive modeling. So buy Dennis's book. It's really good to have in your library. And he goes over all these things, but notice SHAP and LIME. Those are the wrappers that go around a black box model to help you understand them more. But you know what? There's a lot of other tools, and some of them are interesting approaches to the backside. In other words, how can we deal with understanding this black box model better? Well, there's more tools than just being able to use SHAP and LIME. Again, they're like wrappers that say, oh, when I change this feature this way, the output changes that way. And so that thing we were talking about, parameter sweeps previously, it basically applies in a more complicated way here. Now, oh, and this is my favorite phrase to say about Dennis, out of hiding from a successful AI career. Dennis is multilingual, multicultural, and multi-talented, and yet writes with maximum pragmatism to help you learn a topic fast. That's one of the things I put in my reviews. And this is yet another, by the way, you can all get to this presentation. I'll show you the bit.ly link at the beginning, but if we go through each of these chapters at a very high level, first, he's just doing AI case study from scratch to trace infection, like the story that Sai shared. And then real life decisions in AI, white box explainable AI. Facets. Now this to me was probably one of the more powerful chapters, because facets is a pre-configured tool to help you do rapid visualizations of your data set. But now SHAP, it's one of these wrapper tools. It's saying, I don't care what model you give me. You just let me use the model and I can explain the feature importance doing that. That's super powerful, but it can be complicated too. So that's why we like being able to use simpler models outside of that. And then from scratch, meaning applying Google's what if and facets together to reduce bias and cover moral, legal, and ethical issues. So I could keep going on, but we want to leave time for discussion. If you really want to get deeper, this is just an introduction to explainable AI and the spirit of it. But if you want to get deeper into it, you want to get this book. And another model agnostic feature explainer is Lime. But Dennis, true to his form, he goes through some great case studies. He's got workable code that you can get from in Colab format. Okay, now there's two examples in code that when I'm giving a longer presentation, I go through chapters 3 and 4, the facets, explanation, and the SHAP. I'm not going to do those today, but if you want access to those, I don't think Dennis would mind me sharing the code for these two chapters with the family, but he might. No, he's saying he'd give me a thumb up. Excellent. Now, what did I mean by thinking beyond? So basically, all I'm trying to say, if you want to get deeper in this, go through Dennis's book, go through his code examples. But where, in my opinion, does all this come from? And I'm not saying Dennis did it this way. I'm saying the community's moving this way. There was a very famous book written decades ago now that y'all might not have heard of called The Goal. And I think what Dennis's book covers, the goal of explainable AI, when we really peel apart the onion of all of this, it gets back to what was taught to process experts in the goal. And I can't encourage you guys enough to add this to your reading list, to add it to your library. It's basically this, it's a fictional story of a young plant manager who's trying to introduce robotics to improve productivity in his plant. And a guru comes along and helps him see that's not your ultimate goal. And he helps him to really apply the correct metrics. But there's follow-ons to this, more modern versions of them. They're called the Phoenix Project and the Unicorn Project. And these are great modern examples of what the goal was talking about, but in the realm of software development, which, as we all know, is a close cousin to data science, machine learning, pipeline development. So there's truth in data. Vertical brilliance brought us to a point of inventing and progressing AI, machine learning, reinforced learning, and deep learning. But what we need to ask is, will org leaders and data scientists embrace the goal of understanding each other that see big returns in data? And so what do we need to do? Why is explainable AI so important? Well, we're peeling apart the data. We're analyzing it from several perspectives, and we might find that we need to do some predictive modeling. But it's not just the models we need to explain. We need to make sure the domain experts and the organizational leaders have enough understanding to appreciate the value that data can provide them in guiding their decision, not be data driven, but be very data informed. So if the minds are going to meet to seek a greater return on data, they should at least seek to understand each other. Now that's a burden on all three of these groups. The organizational leaders need to appreciate what their domain experts and data scientists can bring them, and vice versa for the data science and domain experts. But ultimately, the domain experts and the data scientists should be serving the goals of the organization, and those goals should be informed by data and domain expertise. But we're not going to get there unless we have good explainable AI for the whole process, not just downstream of the predictive modeling. So Sai, we good?
Yeah. I just had
I'm
a
gonna-
question, like, which I wanted to
Yeah.
ask you.
Yeah,
You showed that last slide about mutual understanding. How important is soft skills play because role in it? Because data science teams, because somebody working on AI can't produce results every time. Like he might face some new challenges. So how important, according to you, is a soft skill which can play a very important role? Like,
Now, I don't want to downplay the importance of learning really good soft skills, but how many of you are comfortable enough approaching, say, the vice president or CEO in your company and saying, I just want to understand this better, and I'd like to give you my opinion on this. I think there's way too formality. Why are we coming up with a formal presentation every time we just want to discuss a point? Let me give you a funny story. I sent an email to my friend who was a vice president, had a company I worked at. And I decided I would CC a few people. Big mistake. They acted like ants whose hill had been stepped on. And they were scurrying to help rescue Thom from his impromptu conversation with the vice president, who they didn't realize is just my old friend. And so I went along with it, and we did this big rigmarole. And Rick is the name of the vice president, had some very challenging questions. I thought they were good questions. And then we all wrapped it up, and it made some guy who was very territorial, very upset with me. A week later, I passed Rick in a hallway in the building. Rick, all I wanted to say was, why can't we do this? Because we own all these things in the field and we can experiment with them. He said, Thom, I've had that same question. So I learned, boy, what a waste of time and effort, Sai. All that formal presentation when I could have said, Rick, can we just go out for a beer and avoid the email and avoid the CCing and say, you know, we could do some design of experiments. We could do an experimentation platform on all this stuff. That's soft skills right there. Go have a beer after work. Invite someone to lunch and just have an informal conversation. Get frequent feedback. Don't think that it needs to be in the form of some formal presentation. That's what I'm really trying to drive home. Let it be over lunch, over beer, over coffee, over a meeting in the hallway, but do it more frequently. And so to me, Sai, you'll get better at soft skills doing that than trying to get really good at formal presentations. To me, that's the essence of beginning to get good at soft skills. I hope that helps. So thinking beyond, if most of these methods are seeking to explain how changes in feature values affect the output of artificial intelligence machines, we should regularly communicate our work on features throughout the whole pipeline as important feedback to the organizational leaders and domain experts. But this is those aisleway, hallway, over coffee, over beer, over lunch discussions. Please don't if you've done those kind of conversations a lot, then when you go to do the formal presentation and those people are there, they're going to defend you when certain little dogs want to mark on your presentation. So finally, and we want to get into discussing this as a family. So what? If a model that is hard to explain outperforms a model that is easy to explain, and that can be shown, why would we demand an explanation? This is getting back to what Guy challenged me on politely at the beginning. And if we insist on understanding the output of machines that can outthink us, aren't we holding back the value that those machines can give us? Well, let's look at it from a different facet, from a different perspective. Explainable AI is more than understanding math output. Math machines can calibrate our thinking when they make counterintuitive decisions. In other words, they're counterintuitive to us, but they can calibrate our intuitions. Now we can improve our intuitions based on what we're learning from these machines, but we've got to remember that humans are creating them. And then, but let's remember, in this age, we're making machines that can do things mentally that we can't. But in previous ages, we made machines that could do physical things that we can't. It's okay that we move the machines from the doing to the thinking, right? So let's let them help us grow. Let's remember they're our servants. They're not our masters. And thinking that is better calibrated to reality helps us to conceive better solutions. So to me, that's the big so what of this whole thing. Now, Sai, do you have any closing questions or remarks since we had this conversation with each other?
As I think everything is sorted. There is no need for closing remarks because you explained so beautifully. But yeah, I would definitely seek feedback from others, like how was it? Because it will help me to improve.
Now before soup time is rapidly approaching, let's get Dennis's input and questions and thoughts before he has to go eat soup.
So first of all, my first reaction is a lot of emotion because I didn't expect this. I was just dropping in, and it's listening to you is like seeing someone write a music score, like my book, and then hearing the music played, by these talented musicians. So my first reaction is a lot of emotion. I'll probably be speaking about it all evening to my family. So that's the main takeaway for me. And now for Sai, going back to the chapter 1 is a real problem. I phoned my nephew's a doctor, and I phoned him and I said, what's going on? Give me a problem where you have a fever, you have a patient coming in with a fever and symptoms, and you just can't figure out what happened to him. And then he said, yeah, well, I had this patient here that got an infection, and I had to do this whole investigation. I had to figure out physically where he went to. I had to ask him questions. I had to make phone calls, and I finally found that he was contaminated by an animal when he visited a park somewhere. So I said, what if you had like Google Maps and you had all the information right there? And then I gave you a little algorithm that said, well, with these symptoms you get, he said, yeah, well, that would be a tool. So general practitioners use specialists all the time for x-rays and everything. So we thought that this could be something we added. So to go back to what Sai was saying and Gaeth and you, in my career, I'm the fireman. That's where I got. I'm a fireman. I come in, for example, right now there are semiconductors that are missing on production sites, on assembly lines, and people would just call me in and say, "How can we schedule now? We're gonna have to send the workers home." So when the best models don't work anymore, usually people say, "Well, call Dennison. He's gonna find a way to recalculate production so that you can go on and you don't have to stop production." So we're in a nonlinear world where we're going to need to fine-tune things in real time. Even in Germany, where Gaeth is now, semiconductors are missing. So it's just my first thing is emotion, because I'm listening to the music I wrote, and the way you say it, I mean, it moves me like my son playing the piano right now. And then the second thing is, I've always worked in a nonlinear world where the central limit theorem keeps going off track, and people get into a lot of problems. You get strikes, you get I work for laboratories also, manufacturing medication, and sometimes the ingredients would come in. What are we going to do? We have to. So I'd say explainable AI. You played the music score. Why don't I? I like it. I don't have much to add. I like to hear the music. You just moved me a lot. That's all.
Excellent. Well,
Then
what kind of
then
soup
you have
is for
to dance
tonight?
since it's
I have to dance.
Yeah.
Here you go, Gideon.
And I don't. I'm. It's for me. It's forbidden to dance. So please don't ask me to dance.
Well, usually I don't dance either because I might squash people's feet, you know.
Oh.
But sitting down, it's easy.
Yeah. So that's good.
Can give the illusion we're dancing.
Yes.
So Private Dennis, I'm very burning with curiosity to know what type of soup Catherine has prepared for you tonight.
Well, tonight is a special evening. My son came in with his companion, a woman from Asia, and we spent the afternoon talking to her family in Asia. And now my son likes to go to his favorite pizza restaurant in our city, and we're going to be leaving right after to go eat our pizza down there. He's been eating since he's a child, so every time he comes back, he wants to go there. You get these dear memories.
Does your son's girlfriend speak Mandarin by chance?
Yes.
Wish
Speaks
I could talk to her.
Mandarin, Taiwanese, and several other languages.
Well, tell her I said ni hao, wo renshi mi gao xing.
Yeah, I heard that all afternoon. So yeah, hello and all. Because it was a Taiwanese family, so we heard Chinese, Japanese, and Taiwanese.
Excellent. Well, who else has questions for us about explainable AI, or just don't feel like it has to be a question? It can be a point you want to add. We'd love to hear from you.
There's just one thing I would like, just one little detail, you know, to your excellent interpretation, is that in Europe we have GRPD, and there's a legal obligation in some cases to explain a result, or you can pay up to 20% of your annual sales and get a $20 million euro fine. For example, if an insurance company, in one of my chapters, I took the US Census data apart. I don't know if you remember that part. I found it ridiculous to have all that data. So I took it out. It's forbidden in Europe. Someone used that in Europe, he'd have so there is a legal aspect in Europe, and it's beginning to happen in the United States against discrimination, where you have to explain why you did that. If someone says, oh, you didn't give me that loan because I am this or X or Y, you have to explain why. So there is a legal reason. That's all I wanted to say. Just a little comment.
That's excellent. Thank you. Now, Guy, I think you had some things to say.
No, Kimberly has something to tell us.
Oh, yes.
Actually, I have a question. Hi, everyone. So my question is, you know, one of the biggest problems that we're having, especially in America right now, because we don't have the regulations in place, is seeing old data being used and going into algorithms and basically creating bias, which, as you had just mentioned, goes against certain segments of society. And as larger corporations and as government increasingly use large data, how can you determine, you know, do you have to scrap all the historical data because it's biased, or how can you extract the bias out of the data and then ensure that when you're using these different models, you're using them on basically clean data? Thank you.
Well, what I did thanks for your question. What I did in the book, I think it's somewhere around chapter 5 or 6. What I do is I take the US Census data set. Well, we're in a private conversation. Well, it'll be public, private. I can't stand it, because you have a column. There's a field where you have there's a column that says to predict. It was an example to predict the income of a person, and you had the marital status. Was the person married? Was this woman living alone? Was she already married, a widow? I mean, so what I do, I just take I took the model, then I took all these fields, these ridiculous columns out, like race. I mean, race. I found Jamaican in race. I didn't know that Jamaicans had a special race, or Mexicans were a race. So I live in Europe, so we can't stand stuff like that. So I took it all out, and then I just left two columns in: age and number of years of education. And I was saying a 5-year-old can't earn as much money as a 20-year-old, and a 30-year-old can't earn as much as maybe a 35-year-old. And if you've done 15 years of education, you probably earn more if you stopped in 6th grade. So I just took number of years of education and age, and I made income predictions, and they were pretty close to what they were doing. So they had a lot of noise in their data. So what I say is clean your data set before, just don't accept it. Just pull it out.
But then when you're doing that, how do you ensure that you're not taking out features that would actually tell you information that might be vital?
Trial and error. Who knows? I mean, you just try again. But basically, I'd rather produce a wrong answer and say, I can't do the job, than putting unethical data in a data set. I might even I've stopped projects like that. I say, well, goodbye, we can eat together, but I'm not going to work with you. You don't have to accept it.
No, real quick, Dennis, what you didn't know is actually Kim already knew the answer to that because we talked about it in class today, and she never misses class. So I know she knew the answer.
So she was testing me. Did I get a good grade? Kimberly, do I have
You have to ask her.
I would give you a good grade anyway.
Okay, so anyway, I'd like to thank everyone because it was very emotional for me here to hear that, and even had a class this afternoon. I mean, I'm like a mouse hiding in a little mouse hole right now. So.
Please thank Catherine for letting you come out to play with us.
I'll do that. Well, anyway, thank you guys. I think it's going to go on all evening and probably to tomorrow morning. So thanks a lot. Thanks a lot. Bye-bye. Bye-bye.
Thank you, Dennis.
Yeah, thanks, guys. Bye-bye.
Bye-bye. Jaya.
Yeah, I think Kimberly kind of alluded to this question. When I think about pre-explainable AI, right? And where Kimberly brought out about the data stuff. When I think about pre-explainable AI, correct me if I'm wrong, typically there's a lot of work involved in the pre-explainable AI, whereby based on the map that you showed, right, you have the domain expert, you have the organization leaders. I think, to me, it feels like these two people need to talk out with each other, and then we have the data science team coming in, right, on the other side. So the pre-explainable AI, it means you need to figure out the data quality, the mission, the vision, what are we headed towards, what problems are we trying to solve. You identify the problem, and then you find the data that surrounds that problem, and you want to make sure that the data it's clean, right? And those things all tells me it's pre-explainable AI. And I think there's a lot of work involved in the pre-explainable AI, a big chunk of it, because if that top goes wrong, then the post will become kind of garbage, right? So am I correct in thinking this way? Because I think the domain experts, the organization leaders, and the data science need to be all in the same page for that matter.
Can I add to your point something? Yes, you got it in correct way, by the way, in a very nice way. Mm-hmm. Just when I use this, let's say this example or this approach multiple times, that we have to approach to challenge any kind of problem or solution we are trying to find, especially with data science. The first one is we have a clear process, a clear workflow, clear knowledge also from the domain expert. All of this is documented, is there, and then we have our the data science field comes to find where exactly something can be automated to create, for example, predictive modeling to add to that work. Now, this is somehow it's considered secure process because all the knowledge is there and even who is going to validate the model performance, it's already there, beside the validation that we are performing or the evaluation that we are performing technically. There is another approach, which is, it's very promising, but it's kind of creating a challenge. That means the data science team in general, they are creating a challenge to the domain expert that, okay, we run this experiment. This is our input. This is our output. This is our explainability, maybe without any kind of domain knowledge or a very limited domain knowledge. And then telling them, this is what we found. Is it reasonable or not, and why? And if it's reasonable, it can be pushed for further finding, or it can be really very, let's say, special research performed. If not, then we will back again to the first approach.
Okay.
So this is the two ways that we are running our
Right.
business in general.
Right.
This is,
So-
I'm adding to your point. I'm not
Sure,
answering.
sure. No, that's fine. I think I see you're giving me the full circle. So the data scientists could be finding some kind of issue or problem or whatever. They bring it back to the domain experts and organization leaders. And then, of course, this is an iterative process, right? It's never a linear process, always in a circular motion. But I guess in the beginning is what I'm saying is there is a problem, and these domain expert organizations are coming in to say that we have this problem, and the data science team is coming in and say, okay, we can try to solve it maybe this way. And then you have a model that comes from the DS team, right? And they share this model. Now, how much of an explainability do you have to give to the domain experts and organization leaders about this model? Because not these two groups may not know the full spectrum of DS. How do you communicate that to the domain expert organization leaders? Like, how do you communicate a model? I know you cannot say the every bit of it because it's very technical, highly technical. But then you want to say it in such a way that they understand this whole thing. But how do you do that? How do you explain that?
Okay, Thom, do you want to get this? I can answer, but that's not my show. Today I'm moderating.
I was going to ask you to answer first because I have an answer, but I'm very eager to hear the Arabic mindset on it first.
No, it's explainable AI. It's, let's say, it's the scientific proof that help us to fake a story or to tell a story. Now, how to explain it? I will answer from in the medical field. Whenever we have kind of, let's say, storytelling session or presentation we have to perform, whatever it's translated in that one, it's totally far from the technical side. It's related to the business 100%. Far from it. Let's say there is these great minds that great people, they are playing the both roles. We name it business analysts most of the time. The business analysts, they are the people, they are able to speak both languages. This business analyst can come from technical background or from the domain background, which is in my case, the medical background. There's great physicians doing that part, being business analyst, and for sure there is some technical people that can be great business analyst. Now, here is the let's say the link between the both is the business analyst always, and they are able to show the domain expert with their own language what is the finding, and translate back to the technical people what is the meaning of the validation from the domain experts. Here is the real gap, is the business analyst. It's very critical. It's something we cannot live without it. This is my answer.
I would only add this, Jaya, very carefully. I feel like you asked us this question, very close cousin to your question. How can I learn to speak better? How can I learn to communicate better? How can I learn to teach this subject better? It really is that realm. It's going to take a lifetime. What we're doing is looking for those things where, the mathematicians and the statisticians and the data scientists, they always use these terms, but you know what? that's not the vocabulary of the people I'm going to speak to. What grandma explanations can I give? Now, when I say grandma, I mean someone who's really smart, but just doesn't know data science. And so it's going to be, Jaya, when I present to a group of non-data scientists something I'm working on, I say, now, I might geek speak you. I need you to interrupt me right when I do it and say, Thom, what did you mean by that term? What did you mean by that concept? Because it's a constant uphill effort, Jaya, to try to find those really great illustrations. However, we can count on everyone we're speaking to learn the equation of a line. And what is a lot of this? It's the equation of a line. Oh, we may have to say, well, these inputs, we're going to square them first because the output looks parabolic. But we can still do that. We can say, oh, these are these features squared, and we did it to make it look linear. You do everything you can to make it clearer and clearer. Like a lot of times, Jaya, I'm presenting about a giant corpus matrix. I don't use the word matrix. I say, hey, this is a giant table, and it's got rows and columns, and the rows are this, and the columns are that, and it's huge. And I don't say sparse, because sparse usually means huge. It's huge, and it's got mostly zeros in it. But the places where it doesn't have zeros are really important. There's always these ways we can speak. Now, if you're speaking to fellow data scientists, it can still be a challenge for some of them because they're at different levels. And so sometimes it's good to practice. You can tell your data science friends, I'm going to talk to you like you're not data scientists so I can practice this, because it's so important. That's just a thought. Back to you, Guy.
Yes, I just want to add one thing before Kimberly first. Go ahead, please. I'm not going to add anything.
You can add, because it might affect my.
No.
My
One time I was forced to explain what is the RACI metrics to project managers, which is it's coming from their field mainly. So sometimes, yes, the domain expert it's very challenging. You assume that there is something, it's really clear, but it's not clear. So yes, you have to make it simpler, and simplest to show the value of your work. Yes, Kim, this is the only add.
So I've raised my hand. I'll lower my hand now. So I was thinking and listening to everything that you guys were saying, and going back to what Jaya was saying, what I find to be so frustrating and increasingly frustrating is that you have the data science perspective where you're going in, you're looking at the data, you're working with the data and getting to know the numbers. You have a relationship almost with the data. You see patterns, you see all of these things, and you try not to have any cognitive bias of your own when you're looking at the data, trying to find a story. And it's very hard because you then go to the management and you say, okay, this is what I'm seeing. Is this relevant? And what's never really talked about, and I think should be talked about, is the idea that you guys had about everyone being on the same page in the front when you're doing the pre-author, the pre-AI. Because what ends up happening is that you have people from different perspectives with different objectives of their own, wanting to fight for their territory. So management wants their numbers. They want to see that what you're doing is actually affecting the bottom line, and they don't actually care about the black box aspect. All they care about with the black box is that they meet federal regulations, or they meet, the perception that they're not using biased information. And so there's this sort of lack of communication that happens between the different stakeholders, where I find that the most important aspect is everyone agreeing that the question at the beginning is the best question to ask. Because every time we go back to this, you see all of the problems that come out. You start talking to them about just the one question, are we asking the right question? And you start seeing all of the different stakeholder perspectives and we're looking at it from this perspective. And I feel like that needs to be addressed. The idea that there are different agendas, and how do you address the different agendas in the research if you can separate the research entirely, as Gaith was saying. And I think this is why there are those two sides. I think that the reason that we have the data analysts working with the numbers and trying to find out what they can see without that domain guidance is because the numbers do have a story to tell that maybe the senior management is not going to see unless you give them the freedom to do that. So I guess I'm asking, like, how do you navigate all that is unsaid? It's not even a soft skill. It's just not even being addressed. It's not being discussed. Thanks.
Can I add to Kimberly's questions? Because even I had a similar thought. Like Sai explained in the story that was depicted in the first chapter, before getting to the searching about the location history from the Google Maps about the patient, like how did the doctor get to it, or how do we the domain expert, which is the doctor, and the person who is ill, so how we get to the right page? That's what probably Kimberly was also pointing out to. And I think, yeah, even I had a similar question.
Kim, you remember those conversations I was talking about having? I think most of this needs to be done very informally. Hey, just like schedule time in their cube, not a presentation. I just want to get some feedback from you. You know, I was cleaning the data, and I went to talk to the data entry team that programs the data entry program. And I think we need to escalate this because they have guidelines on what's a priority. That's one point in the pipeline. Then you go to another point in the pipeline. You say, oh, you know what? It'd be less burden on our automated pipeline for this if you could scale these right after they're entered according to this scale. Now, you may still want to scale them on your own. I'm just saying, you know, that's a possibility. Kim, it could be as simple as, could you make sure this field's not null? Could you make sure this string is a float? Could you make sure this entry is a float, is a string? But when it gets down to the, hey, I would like to see if you think this is important to the organization and know this feature Pareto. I'm at a point in our model development, our storytelling, I found this feature is most important, this one's the second, et cetera. Now, my guess is most business stakeholders, most domain experts are going to start drooling over that stuff, more so than the predictive models. In other words, you're already front loading them with model understanding. That's all they need to know. This feature's most important. This one's next most important. As I get updates, as we get more data, but this is an initial report. Make it informal and frequent. But while you're there, Kim, you can have this spirit. And Jaya, you say, this is where I'm going. What else would you like to see? What else can we do? But I think you're always trying to get a model out or a story out as fast as possible. Why? So you get feedback sooner. If the first model you do is better than average on predicting, and you can learn to interpret an R-square scored that way, if it's better than average, put it in production. Just make sure there's a way to frequently update the model that's in production.
I will ask question here. Sorry, I interrupt you, but it will be related to the question from Kim. The question is like this: there is some fields, whatever the model that you are building, it. Let's agree on that. If you agree with me or not, I'm asking here. Whatever the model, it's building a correlation between the features and the output, but it's not telling the causality. And this is pure technical, but how it's reflected to the business itself. Most of the time, for many fields, I cannot accept the correlation as a final causality. I have to validate it. Now, what is the value of data science here? It's the automation. It's being faster. It's being data-oriented. That means I know, for example, there is such a features is very important for heart attack prediction, for example. But what is important, I can predict how many heart attacks I will get within a month for one hospital or for one city. I'm not replacing a doctor. I'm just checking the, let's say, the hospitality needs in the hospitals. So why I'm giving this example? Because being on the same page, we cannot overwrite, let's say, the domain experts. We have to communicate to them, even if they are on another page. Now, I agree with you about the first question. It's very important. Most of the time, even in my daily routine, I'm telling, let's keep strict to our original scope for the project and for the model. Sometimes they check for it and they couldn't find it. Why are doing that? I know it's not documented, but at least there is a discussion happened and it's building the scope of the work. So where it's to reach. Until now, we are adding models, doing analytics just to do small task. It's very valuable. We know it's not accurate 100%, and we know it has to be better. Okay. According to that, we cannot trust the model and trust the data only because we know all the hidden gaps on the data collection process, on the pairs, all of this. So I don't think it's suitable in production to, let's say, overwrite. You can challenge the domain expert, bring them to the same page somehow, find a way, managerial way, not technical way for sure, but don't override them and don't think about overriding them. Yes, Jaya, sorry.
So I guess just when you mentioned data collection and bringing the domain expert in, right? So I guess I'm trying to understand data provenance, right? That's where the data, where is it coming from, right? Who's the police officer who checks the data? I mean,
ask Hugo.
Is it domain experts, organization leaders, or data science? How do we know the data provenance, how clean the data? I mean, not how cleaning part is easy, but the data itself. Where is it coming from? What kind of information that's in the data, which is the rows and columns, right? And how biased the data is and so forth. How do we tackle that first? I mean, the data itself. Who does it?
You have to go to the source. You have to go to the source of the people who put the data together.
Okay, and the source is, the data is coming from somewhere, right? And is it something that the company collects that data, or is it is that coming from different websites?
If I want to, let's say, to create approach to answer, but I'm not going to answer. First, we have to know that we are trying to get the best from all data collected all over the world for any reason. This is the great about the data science, that everything, even if it's not structured data, we are able to use it, but we have to be very wise and very professional in using it. Look, let's do it like this. Now, it's not an answer to your question, but from our point of view, for sure, I don't have any control about what is the data, but I have to know exactly how it's collected, because it will help me to predict which kind of data cleansing and data preparation I will do. But for sure, since there is more data, it's good for me in case I'm understanding exactly how it's collected and why it's collected. But I don't have control about the quality of the data. This is from my point of view, but yes, for sure, I think this is open question. Everybody is able to answer from his point of view.
Yeah, I think that's really hard. In fact, trying to identify, I mean, we know the source of data is coming from either from the company and also, of course, external sources, and making sure that, like what Thom said, garbage in, garbage out, right? If data is not good, then of course your model is going to be bad. I guess the first step is the data itself. And I guess I'm not sure if there is a team within the company that does this analysis before it goes into a model, or if it's, yeah, so that's a bit of a gray area, I feel.
So Jaya, we're at an age, we're at a point in the progression of data science where there's not, well, think about the medical field. If we go back 100, 150 years, you wouldn't have seen the degree of specialization back then that we have now. And we're very new in this data science age. And so from organization to organization, you have to go and find out, okay, who's doing what? You have to just create your own map. It's not some clean categorical specialization of people doing everything. It's just going to change from location to location. And there's going to be technical debt that's almost impossible to get rid of. And there's going to be bad practices, but you just learn to do your best with what you've discovered.
Beside that, since you mentioned that the medical field, I will give a small example about it. For example, once we know that this data set it's related to electronic medical records, EMR, or health records, EHR, or claim information or something. This is our kind of standard. There is a license for using it. That means we are at least know that this is what is the source of this data set. That, for example, it's coming from either insurance company or health regulators. And we can understand even the process behind it, even if there is a gap. For sure, there is a gap always. But okay, 50% of the task it's performed by this 2 words we mentioned, for example. Otherwise, we are going, no, this is a medical reports data. That means it's coming related to the lab test or radiology test or something. Here, it's totally different. We have to consider the languages. We have to consider even the collecting information from this data or extracting insights from that data before the modeling itself. It will be totally different process. It will be another modeling process to perform. And let's go on. Let's consider, for example, this is data from any operational system in a bank, for example. At least we know what kind of processes performed in the bank, and according to that, how the data will look like. Not for me, because I'm not expert there in that field, but for who's always working there. Okay, so this is the triggering point. Now, at the end, I agree with Thom 100%. We have to go, check, find how it's happened, and also try, check, try again, check with the main expert until you are happy with the data set that you have. It's not simple, but it's 90, 80%, 95% of the work. The modeling is the simplest part, let's say, in the production. It's really the simplest part. It's not a problem at all. And that's why some companies, just like what Thom said, it's a problem, it's a very important part. But yes, it's not the, let's say, the painful part. Just like what Thom said, most of the time, there is some companies, they are really fixed to one modeling method, one algorithm only using always. So this has happened. Any other question, please?
So I sense this was more helpful than I anticipated. I thought it was just going to be a pleasant thing, but it really does kind of expose a lot of holes in our whole data specialization areas. And, you know, so Geith and Greg and I are planning to write a book together on return on data. And it will very much have a de-emphasis on the number of machine learning models that go into production and a much greater emphasis on how to just get a greater return on data. I think I try to tell data scientists this: if you're really good at data storytelling, if you're really good at machine learning pipeline, pre-modeling storytelling, that's probably going to get 80% of your value that you give to the organization anyway. Well, it may be that once they see that, they're often working on the insights you gave them before the predictions. Let's think about this. When you have a model that's predicting, a lot of those models are ways to react to situations. But understanding the model itself is telling you how to potentially eliminate those things. And so if we are delivering value through all these great tools we use, and we don't have to do a machine learning model, to get that value. Should we really be worried about the number of machine learning models that got into production, or should we be worrying about the return on data? That's the point. I'm gonna let Guy respond to any comments on that.
No, I have one extra. It's depend on who we are. Okay, mainly, yes, we have to, let's say, look for what's value returned from data, sure. But again, if he is employee and he want to prove himself, he has to go and try to show what he is able to do. Okay, this is, again, here, it's also the transparency level of in the organization. It's playing main role, that how much the target of the company, and then how it's split it into department and how it will reach to each one. It's really important to decide how really we have to work. Otherwise, just like what Kim said, everyone has his own target. Okay, I think there is no comment on the chat, but if there is any comment, any question, please go ahead. If not, we are 90 minutes almost, so I think we are in good stopping point. But for sure, if there's nobody going to add.
Kimberly, it seemed like you wanted to share something. Was there something?
No, you know, it's interesting because I do think that that there is a great barrier. I don't think that management really want to hear the details of stories. I think that you know, in the corporate world anyway, people have to give themselves credit for what they do on their own, because they might not necessarily get the credit in any other format. And to your point of, you know, showing the value of data, I think that if you don't enable people to pursue knowledge for knowledge's own sake, which is really what data analysts do, you know, we're trying to see relationships, correlations, things that exist out there, and trying to ascertain, is it relevant, is it not relevant? And you know, we kind of rely on the domain expert, but domain experts these days could be, you know, someone who's only been there for 3 years, and you know, they're considered the domain expert, and it's like, no, you don't actually know that much about this. And so you're kind of chasing after these empty goals in a way. And so, you know, I think that there is a level of frustration. I think that the more guidelines that people can sort of have in the way that you guys are discussing, of like, okay, you know, there's a value to trying different models to keep things interpretable, but there's also the value to looking at it and figuring out, you know, what is important here, what's not important here, how do we get all the stakeholders at the same table? And I think it is relevant, as Gaith was saying, to each individual situation. You know, sometimes it could be a personality, as you've talked about many times before, Thom, or sometimes it could be, you know, a constraint that has not been identified. In terms of going back to what you were saying, Gaith, about the features. Like, in my mind, it's having a very clear idea of what the question is, and having a very clear assessment of what those constraints are at the end after you've looked at all the features. And for someone who's learning, who's going through it, it's very hard to know if you're doing that correctly. And I think that unfortunately, when you go to the domain expert, they don't know if you're doing it correctly either. So it's kind of the blind leading the blind. And so I was just, you know, expressing that frustration because I don't really know what to do with it. I don't know where to categorize it or place it or how to solve it.
But okay, but Kim, again, when we are facing this scenario, it's almost good to break down this problem that you are trying to find, not a solution, let's say, to find a correlation or any kind of relation between the features and your output. Break it down into smaller problems. This can be, when you talk about domain expert, we are not expecting that domain expert, he has to be, let's say, the lord of that field at the end. But he can be really useful from at least his basic knowledge. Again, it's not something, we are not dealing with the domain expert as enemies, but it's a set of challenges. He is challenging our data sets and our processes, and we are challenging his information. And once we are both blind, we have to break it down into smaller pieces until we will use the smallest piece that makes sense, and at the end build over it to get more clarity and go on. Assembly, it's not something I created. This is what is decision tree at the end. So we can follow it in practice, not going for algorithm to do it. So there is multiple solutions. Sometimes you are forced because of the restriction that you have or constraint which is not clear. You are forced to wait the first bottleneck, the first deadlock you have, just to suggest changing the process. Again, process is playing main role here. How everything is organized, how the relation between the department and the team members is playing main role here. Since we are talking about production, this is very important. In modeling as a research, at the end, in daily basis, we might read hundreds of papers. They are doing great. At the end, we cannot trust them, these papers, to implement them in production, because it's showing ability, but it's not trustful. We cannot use it in production. Just we have the ability. We need more and more work to reach that point. So that's why there is multiple techniques we can follow. For sure, it's let's say the concern is there, but it cannot answer with one answer for all kind of organization, all kind of companies, all kind of fields. At the end, we have to have our own sensors, check what's happened in our organization, and find the best way to back again with a positive impact to the organization at the end. Always getting more, listen more. By the way, this is something we are on YouTube. I have to say it when it's, but it's easy. Since I'm a new job, currently I spend 90% of the meetings, which is very lot meetings here, listening only. 10% of the meeting I'm adding, but I have to do that. I have to understand what's happening.
Real quick.
Yep.
Guys, would you say it's a good idea then to sort of map out the process that you go through? Let's say you have an assignment. Would you say it's a good procedure to map out the assignment that you're going through, the ways in which you're tackling the data, the constraints that you're finding, and sort of giving a rundown of the situation that you have, how you've gone to, how you've done it, and the conclusions you reached and how you adjusted it, so that you can show your value? Because sometimes I think if you attach too much importance to the data result, then you're not looking at all of the work that went into getting the data result, whether it's positive or negative, whether it's telling management what they want to see or not. How do you illustrate your value as a data scientist to an organization in a way that you're telling a good story about your efforts and your learnings, even if the results that you found weren't what they wanted to see?
If I want to answer this, sorry, Tom, I know that you want to add something first. If I want to answer this, I will tell you what I'm doing. I'm starting from the results, the summary, and then the effort, explaining the effort. And explaining the effort, I'm personally trying to explain it just like explaining a journey from one place to another. That means it's very simple explanation, but it will tell you what I consider here, what I consider on that signal, on that part, what is it, whatever. That means I will keep it simple, but I will keep it at the end. If there is a place and there is a reason to show the effort, I will mention it. So again, it's very good to first to understand the mentality of the domain itself, try to show them the result that they are looking for as a result, not as you are following their findings, no, as what you find. Then give the summary, give some kind of explanation, then go and explain your effort when it's needed. That's why even if I'm preparing presentation, I keep it to the end, because sometimes I will reach that point if they are very curious about it.
I'm just curious, when you're, I don't know how a data science project actually works, but do you have a project manager? Do you have to, like, on a weekly basis or on some time frame basis, put in a status report or something? Because, even if I don't know how that works, but I know in just a traditional project, you have to give somebody an update on what's going on. And so one simple thing, you've got red, yellow, green. Okay, what are the things you're working on? Where are you making progress? Where are you kind of, working through some issues? Red, what do you need help with? And, I don't know who you turn it into or how you document that. If your stakeholders, if you have to give them some idea of, what you're doing or where you are. Because the only thing I'm thinking of is if you start this project and they don't hear anything for, 2 months or something, it's like, how do you account for that? But at least if you're keeping them in the loop on a regular basis, and
But
I don't know if that's something that you do in the data science world.
Yes, I want to add something. By the way, the data science, let's say life cycle, the project life cycle for data science, it's very similar to any software project.
Yes.
There is some extra considerations we have to have it there, but at the end we are following agile methodologies if it's needed, other methodologies. At the end we are doing the same. But this is the optimal case. This is not always the case.
Yeah.
Unless you have, especially right now, data science is going inside each and every company, and at the end, even if the company is not related to technical field, they have a data science team somehow, or trying to have data science team somehow.
Yeah.
And at that point, it's very hard to tell them why I need for each data science team at least 6 people to cover all of this consideration. So this is the optimal case when we are really following agile methodology in general or any other methodology, and we have a clear also governance for our activities.
Mhm.
It's very optimal. It's not happened most of the time. We have to fight for it. This is what we are trying to do.
Yeah, typically, like in my situation, you're just given a JIRA, and you're given tasks to do, and you basically have to fulfill those tasks. And then you literally, it's so existential. You're like clicking, okay,
Yes.
Here's what I've done. Here's the link to the code. And you don't necessarily know if you're going to get feedback. If you're not going to get feedback, you ping people, you try and say, what do you think? And they say, looks good. That doesn't help you, like you actually really need to ask very specific questions, which is why I was wondering if it makes sense to create this story where you're, like even in the code, I'll document what each thing is doing in the code to try and make it explainable, even to myself going back, if I'm going to go back and improve it or whatever. But I find that that a lot of times you'll have a question and people will say, well, figure it out. That's what you're supposed to do. And that's very frustrating because you're looking for guidance, and maybe because it is such a new field, maybe because companies are taking on, this data science function without knowing why they're taking it on to begin with. They're just kind of like, oh, we have to have one of those, like a new shiny car. They're not really thinking about what the use of data science is. And then your job is to suddenly tell them why you're there, which, is difficult. It's frustrating.
Just if I can, Kim, if I can just ask you, like when you have a question, are you is it like a data kind of question? I mean, you're expecting some kind of answer, or you're expecting direction? Is that what they're kind of saying? No, you have to know, you have to figure it out.
It kind of goes both ways. It depends on the circumstance. So for example, most times I'll end up asking other people who are working with me, okay, here's what I'm finding. And then we're trying to figure it out together. We're like sort of passing each other the baton and going, okay, you work on this, you work on that. And then when we feel like we've exhausted everything, then we go to the management and we say, well, what do you think? And then they say, well, you tell me what you think. And then we try and explain it. And they're like, well, are you getting the results that you wanted to go after? And so it becomes this loop of a conversation. And, you then take it on yourself and you say, okay, this is my objective. This is what I'm trying to do. Here's my result. And you end up taking authority for something that, you didn't know you had authority for in the beginning, but it seems that no one else is taking it. And so you end up having this level of anxiety because that wasn't the initial role. Like your role was to do one thing, but now you're doing multiple things. And, that's kind of corporate life these days, but it's just, it would be great to have the sort of best practices, so that you're going into it and making sure that you're doing everything the right way, because no one's telling you if you're doing it the right way or not.
So real quick, I just want to give you all the super simple summary of all this stuff. Customer-centric design. If you figure out who your customer is, you don't have one conversation. Picture Sean Bean in his Lord of the Rings role. One does not simply talk to the customer one time in customer-centric development. This is why I emphasize feedback. You talk to the customer. Their first description and your first understanding of what needs to be done is going to be crap. Not on purpose, just is. And so you act like a good reinforced learning agent. You start out with that initial plan, you do a little work, and you informally, over beer or over lunch or whatever, just hop into their, I would say cube, but we don't do that anymore, into their virtual meeting space and say, let me share my screen with you. This is where I'm at. Just this crap. I'm just, starting out. I want to check in with you briefly, frequently, to make sure you see where this is going in case we get off track. Oh, I love it. Oh, but are you going to do this? Yeah, I'm going to get to that. And are you going to do this? I hadn't thought of that. Thanks for bringing that up. Revise the plan, work a little longer. Show it to them, get feedback. Revise the plan, work a little longer. Customer-centric design. You just got to figure out who your customers are and check in with them frequently. That way, when you give the final report or presentation, it's not a shock. You're not finding out, oh, you didn't want exactly this, you wanted that, blah, 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 blah.
Yeah.
I'll give you a funny story. I had to do this super hard manual tuning analysis. And I got tired of little dog marking on my efforts when I would present this. So I finally just started working directly with the architect. Doug, I'm doing this. And he'd say, well, how about this and that? And I could just very informally say, well, but what about this? He said, oh, now I see why you're doing that. Very good. Okay, yeah, keep going that direction. Kim, by the time I finally got done with that monster tuning and I'm presenting it to all these engineers that have egos and want to poke holes in it, I didn't have to defend anything. Doug had the most clout in the room and he defended every statement I made. But it's customer-centric design.
Yeah, very good.
He represented the customers better than anyone, and everyone knew it. So as soon as he would defend something, they were like, no, it's this. No, he had to do that for these reasons. Go on ahead.
Thom, maybe this is the first time I'm telling you this. I'm make it fun and name it ping pong design, let's say. I threw something and receive until it's become good. Yes, and this is what I'm trying to perform right now, because also I'm still new. I'm still facing a lot of new things. So that's why the best thing is just, okay, give suggestion, find something and get the feedback, receive it.
Kim,
and back again.
You've seen that diagram of a reinforced learning agent. It starts with a random crap policy, but it operates on that policy. Why? So it can gather data. And it's just making estimates from estimates. That's all it's doing. And then it stops and it evaluates the policy. It refines it based on what it experienced, and it forms a new policy and it operates on that new policy. We can do it better than reinforced learning agents. We start with a crap plan, just do a little bit of work, and then get it evaluated. And then, but Kim, what you and Jaya were saying, yes, I have, you know what, I'm just going to share this because I think y'all would like it. And I think I have it open. Oh, sweet. Watch this. This is my AI that I call, oh, y'all are probably in that screen, that I call Ambrose. This is probably at least a 10th generation plan. Boy, that is freaking out. 10th generation plan. Not just, there's a written version of this too, but this completely describes at a very high level my plan. And I've redrawn it so many times so that I could manage my efforts better. But after a time, everyone became very familiar with this picture. They knew what all the elements meant. Why? Because I frequently showed updates to it. I would frequently insist, yeah, let's do an update. Let me show you this. And so, I've been interviewing, and I showed this to a guy that was considering me for a manager position for automatic speech recognition. And he's like some VP, and he said, we need people that can give visual plans to that quality. I mean, sharing this drawing piqued his interest to where he put me in front of the rest of the team. Just being able, but also explain just what I'm explaining to y'all. I've learned to mimic reinforced learning agents. You know, if Dwight Eisenhower, and we all respect him, said plans are worthless, but planning is indispensable, then, well, why can't I copy a reinforced learning agent and keep improving the plan based on the indispensable planning? After a while, you know, a first generation plan, what Dwight really should have said, in my opinion now, is your first plan is crap. But if you keep planning and revising the plan, it's indispensable. I think that's what is really the spirit of it. And then it's ping pong. That's right. But it's like ping pong down a funnel, going back and forth, or spinning down a funnel. It's going through that cycle you've seen in my growth model. That's really why I came up with it. It's very reinforced learning-ish. It's learn, try, rest, review, rest, recover, review, and then look, based on the review, learn what you've got to do and try again. But that learn is like what you've learned, the learning is actually readdressing the plan in this particular case. All right, we can pick this up another time. Kim, if you want, lead off with question. You too, Jay. I'm going to put the burden on both of you. The next time we have an open family chat, bring this up if you want to. Just remind the family